Let's practice converting some quadratic equations that are written in standard form into their factored form. And real quick, the standard form for quadratic equations is going to be y is equal to ax squared plus bx plus c. And then the factored form is going to be this slightly different one where it's written like this, where you have y is equal to, oftentimes we also use that a, and then we'll write x minus p and x minus q, where p and q represent our x-intercepts. So for number 1, we have y is equal to x squared plus 7x plus 12. It's nice that our a value is 1 here, so the factors of 1 are going to be 1 and 1, and the factors of 12 that add to get to 7, I'm going to go with 3 and 4 here. Okay, so if we pair these up, 1 times 4, 1x times 4 is 4x, 1x times 3 is going to be 3x, 4x plus 3x does get us 7x. And so for our factor form here, we're just going to write y is equal to, and we're going to set up two binomials, right? Because it's got to be factored. Now our coefficients here for the x's are just going to be 1, so it's going to be 1x and 1x. And then we're going to have a positive 3 and positive 4, so I'm going to put the plus 4 at the end and the plus 3 in the middle. So this would be our factored form for this quadratic equation. And this is helpful to know just because later on when you graph these things, we know that at the point -3, 0, we have an x-intercept. And from this binomial over here, we know that -4, 0 is going to be another point on the graph. So factoring helps us find those pretty quickly. Let's try number 2. For number 2, we have y is equal to x squared minus 14x plus 45. So I'm going to go ahead and put a 1 here in front. So we know we're going to have factors of 1 and 1. So we're going to have 1x and 1x. And then for this 45, keep in mind, we need two negative values just because we have a -14. So I'm thinking 9 times 5 is 45, but I'm going to put a -9 and a -5 to get that positive 45 when you multiply. But if we multiply this across, that's -9x. This is -5x. Those do combine to get -14x. So I'm going to write y is equal to, and then set up two binomials here. And then we know that it's going to be x and x. And then we're going to have a -5 and a -9. Okay, so this would be our factored form for this quadratic. Now this lets us know that we have an x-intercept of 5, 0. And over here, this x minus 9 binomial lets us know that 9, 0 is going to be the other x-intercept. So those are nice points to know. For number 3, we have y is equal to x squared minus 5x minus 24. So again, we have a 1 in front, which is nice and easy for the first part. Now for this -24, we need two numbers that multiply to -24 and add to get to -5. So I'm thinking we need a negative and a positive. I'm going to start with -8 and +3 here. I think this is going to work just fine. This would be -8x plus 3x, which does make -5x. Okay, so we'll write y is equal to, and set up two binomials here. I think we'll have x and x. And one of them is going to have a +3, and one of them is going to have a -8. Okay, so this would be our factored form. If you want to go ahead and FOIL it just to make sure, be my guest. From here, we know that -3, 0 would be a point on this graph. And from here, we know that +8, 0 would be another point on this graph, the two x-intercepts. All right, for number 4, we have y is equal to x squared plus 4x minus 96. So we have a 1 in front, again, not too bad for this one. And for -96, we need a positive and a negative, and they have to be 4 apart from each other. So for factors of 96, we need a positive and a negative, and they have to be 4 apart, right? So let's see, we have 1 and 96, that's definitely not going to work. 2 and 48 won't work. 3 and 32 are also too far apart. 4 and 24 are also too far apart. 5 won't work. 6 times 16. That's 10 apart. We're getting closer. 7 won't go into this. 8 will. 8 times what? 8 times 12. 8 times 12. They are 4 apart from each other. Okay, so we're going to go with a -8 and a +12 here because we need a +4. So let's go ahead and pair these up. That's -4x and +12x. That does combine to make +4x. So let's go with y is equal to, set up these binomials. Okay, and we're going to have an x and x, and one of them is going to have a -8 and the other one's going to have a +12. So this would be the factored form for this quadratic. This lets us know that -12, 0 is a point on the graph, and 8, 0 is another point on the graph. Okay, moving on to number 5. We have this y is equal to 2x squared plus 5x minus 12. And so this 2 here lets us know that we have to use 2 and 1 because it's prime. Those are the only factors. For 12, we have to be a little bit more careful here. Let's see here. We need a positive and a negative. I'm going to start with 3 and 4 and give this a go. One of them has to be negative, so let's put it over here and see what happens. If we go across, that would be 6, and this would be -4. 6 minus 4 is 2. That's not what we want. If we go diagonal, this is -8 and +3. That combines to make -5, but we want +5. So no worries, we just can flip the sign, make this positive and make this negative. So we now know this is going to be +8 take away 3, which does equal +5x. So that was the hard part. Easy part is just setting this up now. We're going to have 2x and 1x here. The 2x is going to be paired with a +4, so put that on the outside, and then the -3 pairs with that +1. Okay. Now if we want to know what the x-intercepts here are, what makes this become 0, it would be 3 over 2, right? So 3 over 2 comma 0. If x was 3 over 2, then that whole binomial becomes 0. And over here, if x was -4, so -4 comma 0 would be another point on this graph. Okay. One of those advantages of factored form is you know where the x-intercepts are. Moving on to number 6, we have y is equal to 4x squared plus 17x minus 15. Okay, so 4 is not prime, so it could be 2 and 2 or 4 and 1. I'll start with 2 and 2. And then for -15, I don't know, one's negative, one's positive. I'll start with 3 and 5, and I'm just going to put the negative here for now. Okay, this would be -6 and +10. That's not going to work for 17. I think if we do anything else, this is not going to work because we can't really change the 2 and 2. I don't really want to use 15 and 1 yet, so let's go ahead and try changing this to 4 and 1, and I'm going to keep the -3 and 5 here. I think this might work well for us. So this would be -12 and +5. -12, +5, that makes -7. This right here makes +20 and -3. So what's 20 minus 3? That's 17, right? So this would get us the 20x, this would get us the -3x, so 20x minus 3x is 17x. Okay, so we have y is equal to, set up some binomials here. We're gonna get 4x and x. 4 is gonna pair with +5, and x is gonna pair with a -3. Okay, if you wanna know your x-intercepts from this one, what makes this become 0? It's going to be, let's see, it's going to be 3/4 comma 0. So that 4 and 4 would cross cancel. And then what would make this become 0? That would be -5 comma 0. So these would be the two x-intercepts. Let's check out number 7. Number 7, we have y is equal to 12x squared plus 13x minus 4. Now 12 has a lot of factors. I'm just going to start with 4 and 3. Don't think too much about it. We can always change that later. This -4, I'm going to start with a -2 and a +2 and see how that works for us. 13 is kind of a weird number, so I don't know if this is going to work for us here because we got a lot of even numbers. This is going to be -8 going across and +6. That makes -2, so that's no good. And this is just going to be +8 minus 6, that's +2, so that's no good. I'll keep the 2's, I think, and I'm going to change the 4 and 3 to maybe doing, let's do 6 and 2. That's also all even numbers. I don't know if that's going to work. I think we need something to be odd still, so to get to 13, right? So maybe I'll keep the 4 and 3 actually and change this one to 4 and 1. I think if we have a 1 there, we can actually keep an odd number. So 4 times 4 is 16, 16, and this would be -3. 16 minus 3 is 13. Okay, so that logic made sense. This would be 16, take away 3, and that does get you 13. So y is equal to, set up some binomials here. We're going to get 4x and 3x. The 4x is going to be paired with the +4, and the 3x pairs with -1. What are the x-intercepts here? We're going to have 1/4 comma 0. So 4 times 1/4 is 1, 1 minus 1 is 0. And for this one over here, this one is going to be -4/3 comma 0. So if you multiply 3 times -4/3, the 3's would cancel and you'd get -4. -4 plus 4 is 0. So those would be the two x-intercepts. Okay, moving on to number 8. we have y is equal to 8x squared minus 27x minus 20. And so let's see what's going on here. We have 8. Maybe we can start with 4 and 2 and work our way out if we need to. And then for negative 20, let's see, we do have an odd number of 27, so maybe we do need an odd number as a factor possibly. So let's do maybe 5 and 4, and I don't know if this is going to work, but one of them's got to be negative. So let's see, that's negative 20 and positive 8. That would make negative 12, that's no good. 16 take away 10 is just 6, that's not going to work. Okay, let's see here. If we change for 20, 10 and 2 would be the next one, I think. That doesn't help us, that's all even numbers. Maybe change the 8 factors of 8 to 8 and 1. And let's keep the 5 and 4. That worked last time with keeping a 1, gave us an odd number here. Let's see here, 1 still has to be negative. So let's see if we keep the negative on the 5. If we go across, this is what, negative 40? Negative 40 plus 4 is negative 36. That's not what we want. This is 32. What's 32 take away 5? 32 minus 5 is 27. We want negative 27 though. Okay, so this is good. Let's change this to a plus and change this to a minus. And I think that's what we want. That's negative 32 plus 5. Negative 32 plus 5 is negative 27. So let's go ahead and write y is equal to, set up our binomials here. We're going to get 8x and x in the beginning. 8x pairs with a minus 4, that's over here. And the 1x pairs with a plus 5, that's over here. What are the two x-intercepts? What makes this 0? Well, x has to be negative here, so it's negative 5/8. Again, you want the 8 to cross cancel with the 8, and that would get you 0. And then for this one over here, this one's easier. X would have to be 4 for this binomial to become 0. Alrighty, for number 9, let's see what's going on here. We have y is equal to 6x squared minus 14x plus 4. So actually for this one, what you want to notice right away is that they all have a factor of 2. So if I were you, I would go ahead and factor out the GCF of 2, so that we're left with 3x squared minus 7x plus 2. Okay, that lets us know that we have an a value, or that there's a vertical stretch of factor of 2. And also when we're factoring here, we actually don't need to consider the factors of 6, we can just consider the factors of 3, which are going to be 3 and 1, so we know that has to be right. And also 2 is prime, so this took away all our possibilities. We do need to have a negative 2 and a negative 1 here. Okay, so always look for a GCF if you see it. If we go across here, that's negative 6, and this would be negative 1. Negative 6, negative 1 make negative 7. So that one worked out nicely if you factored out first. Takes out a little bit of the guesswork. Okay, and so we're going to have 3x and 1x, and the 3x pairs with a minus 2, and the 1x pairs with a minus 1. Okay, so this is an example where you would factor out a GCF, and then it makes the rest of the factoring a little bit easier, and you definitely want to have no common factors inside here. So if you want to know the x-intercepts, this one would be 1/3, comma 0. So if x was 1/3, 1/3 times 3 is just going to be 1, 1 minus 1 is 0. And for this one, if x was 2, then everything would become 0 as well. So those are the two x-intercepts. For number 10, we have y is equal to 3x squared plus 9x minus 30. So it looks like if we can find a GCF of 3, we can factor that out. So we're going to have x squared plus 3x minus 10. Again, that should make this much easier to factor. We do have a 1 here, so it's going to be 1 and 1. We like that. Love to see it. And then this negative 10, I'm thinking 5 and 2, right? Those are 3 apart, and the 2's got to be negative just because we want a positive 3x. So this would be 5 minus 2, which does get you that 3. So we'll write y is equal to 3 times, set up our binomials. And we know it's going to be x and x. And actually, this doesn't really matter. It's going to be plus 5 and minus 2. Okay, but those would be the binomials, and then these intercepts are pretty easy to find. So that's going to be 2, comma 0 and negative 5, comma 0. 2 points on the graph going through the x-axis. For number 11, we have y is equal to 8x squared plus 8x minus 6. Okay, any GCFs? I think we have a 2 here, right? So we can factor out a 2. If we factor that out, it's going to be 4x squared plus 4x minus 3. Okay, so start with that. Then for this 4, I'm thinking, I don't know, we can do 2 and 2. And then for this negative 3, let's just do 3 and 1. And I'm going to make the 1 negative because I think we want a positive 4, right? So if we go across, that's going to be 6 minus 2, which is 4. Okay, so 6 minus 2 does get you 4. So we'll do a y is equal to 2 times the quantity. Set up these binomials. We'll do a 2x and 2x. And actually, since they're both 2x, it doesn't really matter, I guess, how you pair it. They'll be the same either way. And so that would be factored form. One of the x-intercepts is going to be 1/2 comma 0. If x was 1/2, then y would be 0. Half of 2 is 1, 1 minus 1 is 0. And over here, x would have to be negative, let's see, I'll go with negative 3 over 2 comma 0. So if x was negative 3 over 2, then the 2's would cross cancel, you'd be left with negative 3. Negative 3 plus 3 is 0. Okay. Moving on to number 12, we have y is equal to 18x squared plus 30x minus 12. Think of a GCF here. Thinking 6, right? Y is equal to 6. Let's pull out a 6. That's going to be 3x squared plus 5x minus 2. Okay, so instead of doing factors of 18 and factors of 12, we can narrow it down. So this has to be 3 and 1, and this has to be 2 and 1. So that has to be what it is, right? And so that's nice that we factored out the 6 because it took out a lot of the guesswork. I think the 1's got to be negative here, right? Because look at this. This is going to be 6, take away 1, which does get us 5. All right, so as you get a little bit of the hang of this, it should make more sense to go a little faster in getting your factors correct. So let's go ahead and put the 3x and x. 3 is going to pair with 2 on the outers. 1 is going to pair with negative 1 on the inners. For the x-intercept here, I'm going to go with 1/3 comma 0. A third of 3 is 1. 1 minus 1 is 0. And over here, x is going to be negative 2, so let's go with negative 2 comma 0. For number 13, let's see what we got here. We have y is equal to negative 6x squared minus 11x plus 10. I don't think there's a GCF that we can apply here. If you'd like to, though, we can go ahead and factor out a negative 1, which is technically a factor of everything, right? So if we want a positive a value, which we typically do, that could be super helpful. So factor out a negative, and that would be left with 6x squared plus 11x, and then minus 10. Okay? You don't have to, but again, if you want to, I think that might be helpful. For 6, we can go with 3 and 2. And then for negative 10, let's go with 5 and 2. And let's see where the negative should go. I'm thinking the negative will go on the 2, but feel free to try it out. I'm thinking that because 3 times 5 is 15, and 15 take away 4 is 11. Okay, so we're going to have y is equal to negative. And that just means the parabola is going to be flipped upside down. It's going to have a maximum instead of a minimum. So we have 3x and 2x. 3x is going to be paired with a positive 5, and then that 2x is going to be paired with a negative 2. So that's factored form, okay? The intercepts aren't going to change even though it's flipped upside down. So one of them is going to be 2/3 comma 0, right? Those 3's will cross cancel, we'll be left with 2. 2 minus 2 is 0. And over here, we're going to have negative 5 over 2 comma 0. Right, so the 2's will cross cancel, you'll be left with negative 5. Negative 5 plus 5 is 0. For number 14, we have y is equal to negative 10x squared minus 37x plus 12. We do have a negative in the front again, so if we don't want to deal with it, just factor it out, okay? No harm done, so we have 10x squared plus 37x minus 12, okay? So that's, then we have no need to worry about the negative anymore, just keep it in the problem. For 10, I'm thinking, let's just do 5 and 2, okay? And then we'll change it if we need to, and then for 12, I guess we could do 4 and 3, but 37 is a pretty big number. We could do 6 and 2. That's a possibility. We could also do 12 and 1, right? I'm not sure. Let's try 6 and 2 first, just because I think we need slightly bigger numbers and 1 has to be negative. This would be 30, take away 4 is 26. This would be negative 10 plus 12 is 2, so that's not going to work. Let's go, I think I'm going to change, we do need an odd number somewhere in there, right? So let's go with 10 and 1, and let's keep, should we keep the 6 and 2? I think everything would be even then. Maybe 4 and 3? If I do 4 and 3, what's going to happen there? 1's got to be negative, right? I don't know, let's try this. This will be negative 40 plus 3. What's negative 40 plus 3? That's negative 37. Oh, wait. It's right in front of me. Okay, so let's make that negative 3 and positive 4. This would be 40. 40 take away 3 is 37. All right, cool. So y is equal to negative, set up these parentheses. So 10x is going to be there, and x is going to be here. 10x is going to pair with a positive 4 to get 40, and then take away 3 will get us 37, okay? For this first one, what would be the x-intercept? I think it would be 3 over 10, comma 0, right? The 10s would cross cancel, you'll have a 3, 3 minus 3 is 0. And for this one over here, negative 4, comma 0 would be where this crosses the x-axis. For number 15, we got some fractions going on here. So what can you do to get rid of dealing with these fractions? Well, you can use some just the strategies of your factors and using your fractions a little bit here. So let me see here what we can do so we don't have to deal with this. Maybe we can factor out 1/4. Let's see what would happen if we factored out 1/4 here. If we factored out 1/4, then what would we be left with? We'd be left with x squared, right? 1/4 times x squared is 1/4 x squared. 1/4 times what gets you a half? I think if you multiply by 2, right? So what if we put a minus 2x here? So if you did 1/4 times x squared, that is 1/4 x squared. If you did 1/4 times negative 2x, that would be negative half x, right? And then thinking, what's 1/4 of what number gets you negative 6? I think that would be negative 24. All right, so kind of a weird strategy, but one that does work. You may not have thought of factoring out a fraction, but look at this. That's 1/4 x squared. This would become 2/4, negative 2/4, which is negative 1/2. And then what's a quarter of 24? A quarter of 24 is 6, right? So this does work, and then we can factor this part. So we just know this parabola is wider than usual. It's called a vertical shrink by a factor of 1/4. So let's put a 1 and a 1 here, okay? And then over here for negative 24, let's maybe do 6 and 4. I think they're 2 apart, right? And the 6 should be negative. So that would be negative 6 and positive 4, which does make negative 2. So we're going to get here y is equal to 1/4 multiplied by these binomials. And we're going to have x and x. And let's go with a minus 6 on the outside and a plus 4 on the inside, but technically it doesn't matter, right? Since they're both 1x and 1x. The two x-intercepts would be negative 4, comma 0, and the other would be 6, comma 0. Okay, so there's number 15. So if you ever see fractions in front and you have to factor it, try using this strategy and seeing if you can get that fraction out in front and turn all the other coefficients and constants into whole numbers. All right. Last problem of this video, number 16, we have more fractions. We have y is equal to negative 3 over 2x squared minus 11 over 2x minus 5. So I don't really want to factor out maybe negative 3 over 2 just because 3 won't go into 11 nicely, but maybe let's just factor out a half, right? A negative half. If we factor out a negative, then we don't have to deal with it anymore. So what's 1/2 times what gets you 3 halves? It would just be 3, right? So let's do 3x squared. So if you multiply these two, you get negative 3x squared. Then negative 1/2 times what gets you negative 11? I think that would just be plus 11x, right? If you write plus 11x here. So what's half of 11? It would just be 11 halves. Okay, so that does work. And then half of what number gets you negative 5? Well, I think that's just 10. All right, so let's just double check this real quick. If you multiply these, you get 3 halves, negative 3 halves, which is what you want, right? If you multiply these ones, you get negative 11 halves, which is what we wanted. And what's half, negative half of 10? Well, half of 10 is 5, so negative half would be negative 5. So if you factor out a negative half, this actually works out quite nice, okay? Factors of 3, easy peasy, 3 and 1. Factors of 10 are 5 and 2. I think so, right? Yeah, 5 and 2. And they both got to be positive because everything's positive. I think I'm going to go with a 6 and 5 here to make 11. All right, cool. So taking out unit fractions seemed to work well for 15 and 16, so now you know. And you could try to apply that strategy in other problems if you see them, okay? Now we're gonna take the 3x and x. 3x will pair with a positive 2 on the outers. I'll put a +5 here in the middle. What are the x-intercepts here? We'll do negative, because we have a +5, right? Negative 5 over 3. We want those 3's to cross cancel. And over here, we're gonna say that's gonna be negative 2, 0. Alrighty, so there you have 16 different practice problems where we turned quadratic equations or functions that are written in standard form into factored form. And when you factor, it gives you 2 points where our x-intercepts or our zeros are right away. So if you found this video helpful, please consider giving it a thumbs up. Remember, you can find a link to this blank PDF in the description box below, as well as a detailed answer key as well if you just want the PDF. So as always, keep up the great work, and I'll see you in the next one.